got that loud, so you just kind of password.
Where IT set it up.
Okay, I'm gonna go to the YouTube and make sure the audio is working here.
We talked about running and putting this on the VLAN, like on the network, but it was gonna cost us. So instead we just have a simple.
I guess if you just want to talk, I can go over here and make sure.
Okay. Network. I got the password right here.
Alright.
All right, test.
It's working.
You need the button? No, don't worry. Make that.
All right, you ready?
Yeah.
It's UTC.
Okay. They're on the line.
Oh, I mean, I need the credentials. Are you trying to connect as well?
Yeah, I got it.
Oh, you got it.
Yeah. Oh. Hello, on my single biggest miss job.
Thank you. Yes, I'm in the office back there. I'll make sure that
I think I just made an email not having a contact.
let's go with that.
Better before you spend providing easy way to find the email decision. Right here. Right. Get that. So like all you need around first engagement.
Yeah, I mean, well, it's just. You know, and I'm sure Nina can provide the details, you know, but. That's why, you know, we said that one for us. That makes sense. We have been to. There's that. Before that, we didn't really have to eat. Pretty. Yeah.
I got an hour and a half away.
I know, but I think it's taken, you know. Taking us time to go to some. And I think that was probably the cause. Now that we're saving that. You're
That was from the packets, like there's no change.
right, that's true. But so I think there's potentially opportunities coming through.
Is there any other beauty in the system?
Yeah, there's like 12 of there's UT Martin, UT Parks, and really see like, and these are like, some of them are like. To build it, he's like, yeah, real small.
Okay.
And, but I'm UT Martin is big, but, UT Knoxville, I don't like that, yeah. They're all under, you know, the UT system.
Goes down to University of California system. They get a lot of cities in it. But they are like geospatially too far away.
Right.
I get went up like.
Hour and a half, like
Yeah.
you said. So, I cannot remember his last name, I don't know, if you met him, I think.
Yeah.
At UTA.
Yeah.
So,
He is my kind of office neighbor.
Oh, okay, well, I have, that has been really the approach. Continue, and he's relatively new, but once he comes on board, he's the main contact I've had, more communication with and steady communication than anyone else. So, yeah. So I mean, there's potential opportunities there.
If there are other things, it's still like, are you considered so like, you have that consider as you employee, right?
Yes.
Or like something that, you know.
No, you all payroll since the
So it's
I log in, like, so you, like, everybody at UT hit all the UT systems to go in and read your case that the iris. Okay. You know, portal. And you know, all of our, we have, well, we do have like emails at UTC.edu, they also translate to UT. So it's all the same system.
So like. Okay, yeah.
We can certainly go figure out what's in my slides. Oh, yeah, that last move.
Yeah.
Also, now.
Do you guys do it? Does it kind of service? So I can just like run it out.
That was funny about the national right now. It's like the main one is sort of going on that integration system where it's a portal that no matter where you're at, you can get a key for relevant data, store the data, where you can reserve resources like that. So you know, and then from that portal also the full application. You can see around this app, basically, all through that. And so we have a connected vehicle. And then we've also seen them for autonomous garage. So those will also be services and tools that you know, see when using best that can utilize.
Cool. I feel like the work with you guys on the different tools instead of. You guys already have it, I believe it's never, or we can have some going on after, we have some control algorithm on the AWS. And we don't have.
And what of that, or the behind the scenes, I guess, what we do on this part of the system. The way to train the real-time data, but also a real-time interface, pushing back into the system. Tag, like basically you can tag or try to It's like and then you guys just like it's in relay choosing the big in you passing parameters, and that's all people do. That makes sense. Then you get off, but that's something that we've been working on. Or I've been working on. Pretty excited to get completed and utilize it. But we should, you know, and this is for
To all the people who are watching on YouTube, we're going to start a little late. There was a slowdown on 75 North, so the Georgia folks I think are a little bit behind, but just hang in there and we'll start within 15 or so. Thank you.
Yeah. Another thing like that, if I'm even going to talk about it, probably kind of like
Martin.
Tyler.Martin and Jacob.
Yeah, I just want to make sure.
I'll go ahead and add yours actually. After you send.
They need better off the
Yeah, I probably need to turn that off because
yeah. Now you're, how many blocks? If somebody said, well, I really like to move to in fact,
So it's since I'm recruiting also. We haven't got a good farmer. I'm building my.
I'll send it down, Lydia's never. Yeah.
Appreciate it.
Okay. My wife is a project.
I'm bad on. So it's December. Oh, yeah, that's just fine. I mean, it's. Take 3 hours.
I think we're going to go ahead and get started. If everyone can grab a seat. I think we're going to have several maybe trickle in along the way throughout the day. So, and I know we're getting started a little bit late, but I understand there was a crash on 75. So we want to welcome, this is our TSITE / Georgia ITE joint meeting. And we are so thankful and grateful to have the Georgia folks here to do these meetings with us. This year we've kind of been doing a little bit different, and we're not meeting regularly on a monthly basis, but we do like to do it to get together every 4 months or so. I just want to welcome each of you. Later in the day, I will have the PDH forms back there on the table, so feel free to pick one up. And I do have an agenda back there if you didn't grab one on your way in. And we were supposed to start around 10. I think we're running about 15 minutes late. But we'll try to stick to the schedule as close as possible. Lunch will be here in a little bit, and we'll have it here in this room. There's some water bottles, I think, back there. Anybody needs anything. Restrooms here are on the side. And if you haven't paid, I guess see myself or Tyler there for the Georgia section. And anything else, I think I just wanted to say welcome and introduce our Georgia section.
Good morning, everybody. I just want to bring greetings from the Georgia section of ITE. I don't believe anybody from the board was able to make it up here today unless someone added on last minute. Therefore, I want to say welcome I'm the technical committee chair of Georgia section of ITE, and one of the items I help coordinate is this event, but we actually have someone in charge of this from Georgia ITE, and that's Tyler Martin. He is going to come up and say a few words and introduce our first speaker.
Thanks, Joe. So our first speaker is Mike DeSanza. His presentation is called Moving All the Vehicles in Georgia Since 2021. Mike started his career in traffic in Savannah, Georgia in 2008 when he was hired as an electrician in the city's traffic engineering department. He stayed with the city for 8 years, the last 3 of which were spent as a systems administrator in the IT department. Mike made the switch to the private sector in 2016, taking a job with AECOM. He is currently the deputy project manager for the SIGOPS North project in GDOT Districts 1 and 6. Over the last 5 years working on the project, he has been instrumental in the development of traffic responsive programming and max time user logic in the North region and statewide. He also created specialized workflows for incident management notifications and responses, created daily summary notification workflows for regional alarms, and developed the SIGOPS SharePoint task management site that is now deployed across all 6 GDOT SIGOPS projects. For our virtual folks, please type your questions in the chat and we will hopefully be able to have a chance to ask those at the end of the session. Without further ado, Mike DeSanza.
All right. Well, good morning, everybody. Like Tyler said, thanks for the introduction. And for all of you Tennessee folks up here, I actually live about 35 minutes south in Rising Fawn. I moved up here as part of the SIGOPS North project, moved to Chattanooga in 2018. So I know the area well. I took an opportunity to kind of throw out as well from the picture that you see here. This is actually in Rossville, where we can actually see where this particular system here actually goes from Georgia right into Tennessee. It's one of the 2 systems we have that if we could work a little bit better together, there's actually opportunity for collaboration between GDOT and Chattanooga here, and as well as also on State Route 3, where it comes up into Eastridge. On the other side of 75. So maybe if anybody here today wants to talk, I'll be available afterwards. So getting into it, what I was planning on discussing with you guys today is kind of an overview of what GDOT's SIGOPS projects are. I know there's a couple of us in the room that do work on SIGOPS. And where it's going to start is where it came from. Some of you may be familiar with the term RTOP, which started a while ago in Georgia to address quite a few needs. Starting, and again on this timeline, in like 2005, let's say, look at the state of traffic signal operations in the state. You're kind of like a bunch of different blobs working everywhere, where you got local agencies coordinating their own stuff. You've got Georgia over here coordinating their own stuff. So to help with that, they started, and here's some more blobs, right? So to help with that, they came up with the concept of RTOP, which is the Regional Traffic Operations Program, which started in 2010. And what that started to do was to bring some of these blobs under the RTOP banner, right? Which is a GDOT-led project that is staffed by consultants to do traffic signal operations, traffic signal management, and coordination between the various agencies. RTOP at the first was in Metro Atlanta only, which is a lot of local agency coordination. So all of these different aspects of signal operations came under RTOP in 2010 as a central way to manage all of the different things that are needed for a successful and efficient traffic signal operations program. The most important piece is that little arrow that just popped up, is the coordination with local agencies. That's really where RTOP started to have a lot of power, being able to bridge the systems between maintaining agencies. The Metro Atlanta area crosses a lot of boundaries along a single coordinated system. And before RTOP, it was kind of difficult for GDOT to get some of those coordinations done. but with a single project that can bridge those gaps, it made that a lot easier to do. Along with a pretty good boom in technology at about that time. Another thing that came along with RTOP was a lot of equipment upgrades that happened over the subsequent years. So starting in 2017, because of the success of RTOP, GDOT decided to take that same concept and blow it out statewide. And it became what's known as RITSO, which was the Regional Traffic Signal Operations. They broke the state up into 3 different regions, each comprised of 2 GDOT districts. Our particular area, the one that I work in, is up here in Region 1. This is districts 1 and 6, backwards are 1 and 6. Down here, Region 2 is districts 3 and 4, and Region 3 is districts 2 and 5. And then the original RTOP program was there in the Metro Atlanta area. Last year, in 2021, all of those programs were combined into a single banner that was called SIGOPS. And that's what everybody is called now. That turned into SIGOPS Metro, which is, there's 3 metro regions, and then SIGOPS statewide, which is 3 statewide regions that match the original RITSO region that we had. So looking at the numbers, we've got a total of close to 10,000 signals. We're just going to go ahead and round that one up, including locally maintained signals that we get to help out with. Each of the regions is very unique in its profiles. The statewide regions are fairly similar in that most of our work is with GDOT. We work closely with our GDOT districts and the larger locals. Metro is almost flipped from that. There are a lot more locally maintained signals and local coordination that happens in each of these metro districts, metro regions. The metro region, as far as GDOT districts go, if you're familiar with the GDOT district system, I had mentioned already districts 1 through 6. District 7 is actually covers in here. And they have the fewest amount of district maintained signals in the state. But the metro region itself is on par with the rest of the state as far as the total number of signals, but that just shows how many are locally maintained. So SIGOPS was created with a number of roles in mind. The first is program management, and like we talked about before, that's one of the most important pieces of this, is to actually have a single place to manage all of these things. It really helps GDOT out. It's been able to work very well as staff enhancement. So here's what we kind of do with this program management, right? We coordinate with the local jurisdictions and GDOT. It's a big piece of stakeholder communication. We evaluate the metrics. GDOT's got a very, I'm not going to say it's fully mature. It's well along the way to a mature metrics and reporting system, which we'll talk about in a little bit. We also conduct training and technical support for all of our stakeholders. And it's a lot of meetings. We do timing evaluations and adjustments. Again, depending on where we are, it's going to depend on our level of effort there. This drive is to get away from the standard loop that we would get into with signal timing, right? You'd have a coordinated system and maybe you'd revisit that every 3 to 5 years to see if timing's been updated. And, you determine what the timing on a coordinated system is going to be based on the counts that you get maybe for a week or for a day in 1 year. By having a consultant on these corridors all the time, we're basically doing all the time optimization of our coordinated systems. We do that through observations in the field, and we do that through metric evaluation. Maintenance. We have a big maintenance component. One thing that we've noticed early on with all of these projects is that you cannot have efficient traffic signal operations without working equipment in the field. Primarily detection. Detection is the most important thing out there. We can't move cars efficiently if we don't have detection everywhere. And so that's been a big push for ours. GDOT in the past few years has created what they call the OCR program, which is an on-call response. And what that allows us to do is to create work orders for pre-selected contractors that we can push out as needed for quick response. In some cases, we can get repair work turned around in a day, where we don't have to wait for a whole system of approvals, or for what used to happen was that they used to wait until there was a lot of work to give to one contractor in an area, so that the contractor would be more kind of happy to take that work. They would be more incentivized to take a big contract for a lot of stuff rather than one loop at a time. Doing it this way has been extremely successful for us in GDOT, just for that quick turnaround of these signals. And that is for anything maintenance wise, for fiber repair, for loop repair. We'll use OCRs for the FYA upgrades. We'll do signal upgrades with OCRs. Things like upgrading signal heads to include reflective black backplates can be on there. We've done them for pedestrian push button upgrades, kind of region wide. So it's a very great program that has helped our operations out a ton. The other thing that we do is that we've been able to kind of lighten the load for the GDOT technicians by taking the preventive maintenance work under our contract. So we have technicians in the field that go through and conduct all of the ground preventive maintenance, which has freed up a lot of time and effort for the GDOT staff. All of this happens because of our ability to do remote monitoring as well. We really couldn't have these programs without the communications infrastructure that GDOT has in place. We're able to do remote incident management. We don't have to sit at a TMC to be plugged into what's happening around the state. We can get those data feeds from wherever we are. I could get them right now if we needed to. I can, easily work from here. We monitor and again modify those traffic signals during events. We'll activate teams during extreme weather events. I know we had one last winter where there's a big snow event. It was on a Sunday. We all kind of sat around in our respective home offices, and we had a very big kind of Teams chat going on where we just kind of watched what was going on. It was a very, it was a remote, TMC. It was a remote traffic management center where we were all at our stations and just kind of watching how things were going on. So we also do a lot of response to automated alarms and citizen complaints as they come in, which hopefully there aren't very many of those. The final thing that we are able to do is innovate. GDOT has a big push for innovation across their projects. They'd like to see, consultants doing neat new things that they can share with other DOTs. So it's things from developing new concepts and signal operations. We do a lot of user logic programming in our controllers that allow us to kind of do some alternate signal timings and signal control methods. We also kind of create new standards for the traffic operations themselves, right? Kind of how's the workflow in the team's work to affect efficient traffic signal operations and communicate across the projects. And then we share that information with the stakeholders because, having the information ourselves doesn't do any good. We need everybody to know this stuff. And that helps us. One thing that we struggle with in innovation, and we've talked about this across many projects, is that I could customize a traffic signal for a specific intersection. And it might be a really complicated program. And that intersection will run very well. but it will also be very hard for somebody to come behind me and troubleshoot. So it's a line that we're pushing up against right now, is how far do we take the innovation and how close do we get to a standard, and how far can we cross that line? So that's something that we're coming up with internally. We're finding that it's much on a case-by-case basis. But this last bullet, the teaching the stakeholders how all of these things works, helps us move that line just a little bit farther every time, because the more they know, the more we can do. So the projects themselves are organized into these 4 different areas. We've talked about SIGOPS statewide and SIGOPS Metro, but in support roles are also what they're calling SIGOPS COM and SIGOPS. This is SSM, which is System Support and Maintenance. These 2 projects support everybody else through the COM project is managing the communications. Of course, they monitor the state of the communications throughout the state, and are able to quickly respond to and help with upgrades, replacements, stakeholder communication regarding anything communication based. Most of the COM work is centered in the metro area because that is where a lot of the fiber is, and that's where a lot of the COM work is needed. In the statewide areas, nearly all of the communication there is over 4G routers. So it's basically a single network at a single point that doesn't need to really reach out to anything else across a network. So the system support and maintenance contract is one that started last year as well, that is designed to kind of help with developing these metrics that we're using and developing tools and applications to use across all of the projects. And we'll get into some of what they do a little later on. This next slide is kind of focused on how we've got SIGOPS North set up. It's really busy. But this is kind of our workflow and how we do things, right? There's a lot going on here. There's a lot that we look at. For a team of about 15 people, we get a lot done. So let's look at a couple of the boxes just a little bit closer. So one thing we need to look at is the signal corridor performance metrics. We've got a lot of tools that we use to do that with. And then we've broken it down here too into kind of real-time monitoring, right? So this is stuff that we're looking at all the time. And then we've got stuff that we're looking at that is historical metrics, right? So we get all of these different, and each one of these basically is a different input to what we're looking at. So it's a lot of data to take in. To kind of handle this, we've created what we call the ROC, which is our remote operations center. Pre-COVID, that was actually a place in our office. Now it's just whoever's working, what we call in the ROC today. It's basically just a remote monitoring position where their job for that time period that they're working in there is to handle all of these inputs, to monitor them, to take those inputs and turn them into action. Signal communications. Again, this is critical. We cannot work remotely if we can't talk to the things that are out there in the field. And so we really strive for a very high communications uptime. In our particular region, in SIGOPS North, we are, I think out of about 1,500 signals, 1,410 of them are on 4G. So we're more constrained to power problems and problems with Verizon's 4G network when we're talking about uptime than we are with anything else. Right. And again, the heart and soul of the project is signal operations. So we do that too. And again, signal maintenance is a big piece of that puzzle. And then finally is that innovation piece that we had talked about earlier. All right. So let's get down a little bit into where I work. This is SIGOPS North. This is what it looks like. This is our North Georgia region. So, I mean, you can see how close we get up here to Chattanooga. We're right here. Just, you know, you can, at times you can actually just reach right across the border and I'll be right there because I work up here in Rossville quite a bit, actually. So just look at the numbers real quick. I'm not going to spout them all out to you, but, you know, we've got a lot that we look at. The reason that the interstates are included on here goes to the incident management piece of our work that we talked about. Anytime there's an incident on the interstate, such as the Georgia folks may have run into this morning, we have team members that are looking at those and looking at how traffic is diverting off of the interstate onto the local routes, and determining if we need to change signal timing as people divert. And that happens on a daily basis, and sometimes an hourly basis. So it's something that we're always looking at. It's one of my favorite things that we do, because I really kind of think of that as, you know, we're the guys behind the curtain there. Nobody really knows that that's happening, right? You drive that route and you have to get off the interstate. You have no idea that there's somebody actually watching you do that and changing these signals ahead of you. I also consider myself one of the luckiest people in the state. I've had a number of times when I've been driving, you know, from when I lived here in Chattanooga down to a meeting in Atlanta and ran into traffic on the interstate. And I had a guy I could call. I said, give me a diversion route, you know, and he'll dial it right up, you know, and let me know which way to go. And we'll clear out some traffic ahead of me. And it's great. But, you know, it's not just me that we're helping there, right? We're doing this for everybody else. So this is my project. This is SIGOPS North. We also have one of the Metro projects, that's Metro East. This is what this looks like. This is the eastern part of the Atlanta metro area. All of these green dots here are Gwinnett County, which is a huge local agency. They have a ton of signals all on their own. They have their own TCC. They have their own management software. They're very much a mature DOT all on their own, and we help a lot with the stuff that they have going on there. They've been part of the RTOP project for a long time. They're also a very big partner in innovation that happens statewide. There's also DeKalb County and Rockdale counties down here that we help out with in the east. And again, incident management becomes even more important in the metro area. We get some incidents in SIGOPS North, right? But, you know, we're talking onto kind of more rural highways sometimes. I'm actually going to pop back up here. This area in the north up 85 and 985 is a little denser than others. As far as the routes that we have in order to take people on them. But Metro East, again, is just tough. If you've driven through Metro Atlanta, you know, we've got this 85 corridor right here, which there's something going on there almost all the time. There's almost always a diversion route set up somewhere. And we've also got 285 that comes around here and 20 as it comes down through here. So there's a lot of incident management to do there. One of the things that we're working on now that we started in SIGOPS North, that we've moved to the East project, is a defined set of incident management plans that make it very easy to call those up as needed by whoever's working with, that they're standardized by direction and by movements, you know, so that, you know, a certain pattern number is always going to be, let's say, a northbound off-ramp heavy movement to get onto the arterial at that location. The next step in that is actually automating that process, which there's a number of consultants that are working on that right now. I know Tara's here from Jacobs. They're working on that down in Savannah, automating incident responses. We've been doing that work in both the north and the east here. So it's really good to be able to get those things out statewide. And again, that goes back to our kind of mandate for innovation to work on tying all of these systems in together. The other big part of being able to manage things remotely is being able to see them. We currently have 530 cameras in the North project, which are the pink dots that we're looking at here, and about 599 cameras, including, I want to say about 350 or so of those are Gwinnett County cameras in the Metro East project. So we've got a lot of things to look at. In our GDOT districts 1 and 6, they've both stated that they are very interested in having a camera at every single intersection. Some folks at the central office say maybe not, maybe we can skip a few. But what we're finding is that the denser coverage we have, the easier it is to see what we're doing. It's very justified in our eyes. Number one, for side street monitoring. Number two, just for availability. If one camera goes down and that's the only camera you have for an area, then you become blind there. The ultimate goal, however, is to actually be able to do signal timing, completely remotely, using a combination of cameras and metrics analysis. And that's on the roadmap for sure. Here's a look at some of the stuff that we do, I would say, every day. And we've talked about some of this stuff before. I'm not going to get into it too much. We've got a lot of event management throughout all of our regions. There's almost always something going on by somebody. If you think about in the north, we've got Apple festivals in the fall. There's school graduations happening. We do political events. Political season gets really, really fun. I think we did, I'd say maybe 3 or 4 like big rallies, like presidential rallies. Last year, I guess 2020, 2 years ago now. So that those are always something going on there. The other big thing that I don't have on here is construction management. I would include that under event management because we do a lot of construction management every day. Traffic signal timing and service requests again are on there too. Let's let you look at those. All right, so this is kind of how we put all of these things together. Right. Again, the project being remote, we need to have a lot of tools. We've kind of come up with what we call these toolboxes, where we've got GDOT provided tools here, which Gears is actually GDOT provided. It's just not a signal operations. This is a safety tool that we actually bring in to do analysis of some of the signals that we use. But there are a lot of tools that we use here. We find a lot of value in monitoring, radio stations and Twitter to see what's going on and where incidents might be. We actually get these alerts faster than we do sometimes through the GDOT systems. Let me go back up. We also almost always have Google Maps up. It's a fairly responsive source for monitoring congestion, along with Redis and ClearGuide. These are all tools and maps that we'll have up. 511 is GDOT's system for traffic incident reporting. You guys can probably see that on the website. Or if you guys have looked at it before, they've updated their website lately. If you haven't looked lately, it's pretty neat now. We use traffic modeling software, Synchro. We also use True Traffic. And then we got safety tools like Gears. So let's look at a couple of those on their own. MaxTime and MaxView are deployed statewide for GDOT. It's a very big advantage of GDOT's system is that they've got this statewide platform. MaxTime runs on the controllers, MaxView runs as a central management system. But having this central platform statewide makes it very easy for not only the consultants, but for GDOT staff to monitor everything, to kind of know what you're looking at all times. And it kind of goes back to that concept of standardization that just kind of aids in troubleshooting and in knowing what you need to do for quicker responses. That max time deployment includes locals. GDOT supports the locals to upgrade their controllers. GDOT not only with technical support, but with funding. And so most of the locals in the state are upgraded, what we call upgraded, converted to max time now. There are still a few places in the metro regions that are running other softwares for various reasons. But again, for the most part, well over 90%, I'd say it's about 95% of the signals in Georgia are running these platforms. The push for these platforms came from the desire for data. The max time software has the advantage over the previous software. They were previously running CPAC. Actually, I'd say that the previous version of CPAC that they were running, in that it is a high resolution data collector. That was a very big feature for them, is to be able to collect that high resolution data, which again it's capable of 255, I think, data points, 10 times a second, as far as the operation of the signal itself. The other kind of nice thing about the max time itself is that these controller interfaces are available via a simple web browser. You don't need a separate application to access or interface with the controller itself. So it makes management quite a bit easier. One of the other tools is ATSPM. If you guys have been in the signal business for a while, you've heard of SPMs. It's the signal performance measures. We get a lot of good analysis out of this platform. This is a platform that's great for analyzing individual intersection performance. Becomes a bit challenging if you try to analyze a whole corridor's worth of data on it. But we use this a lot before, during, and after timing changes go into the field. There's a lot of great information on here. Again, Purdue coordination diagram is probably one of the best charts I think that anybody's ever made. Just a ton of information here that we get off of these things. If you haven't seen one before, basically what we're looking at is these numbers, which are the critical ones, which is the arrivals on green. Here's the green time for this particular phase. And then the bottom one is the platoon ratio, which is a function of these other ones. But what the platoon ratio is a measure of is how efficient we're moving cars through these intersections. How well are we platooning the vehicles on this coordinated system to get them through? And you can visually see that here. So each one of these little black dots is a arrival of a vehicle. In between where you can see this green on the bottom and this yellow on the top, that's the green period of the signal. And so what we want to see is density in here. The denser, the better. That is showing good platooning and efficient movement throughout the intersection. RIDIS is another big tool that we use. This is a product that has grown a lot in the past few years. It's put out by the CAT Lab at the University of Maryland. GDOT has bought into it extensively. We get a lot of data out of here. Again, this is good for kind of before and after studies. We use this a lot for planning. What we're able to do here is evaluate the corridors. We can get travel times, speeds, congestion, that kind of thing from this RIDIS data. The other thing that RIDIS has that we're able to do is do live monitoring of it. They have live maps up. You can also pull camera feeds in from our GDOT assets. So it's a very functional platform, a lot of stuff to dig into in it. And we use it quite often for just about everything on a daily basis. The SIGOPS metrics site is another one that has evolved over the years. It started as what was called Mark 1 and became what it is today is the SIGOPS metrics. This is a consultant built product that was funded by GDOT under the old RTOP programs. It was made for GDOT. It gives us a lot of information. It aggregates a lot of that information we were just seeing in ATSPM, so that we can, kind of come to this interface, and instead of going intersection by intersection in ATSPM, we can view it, here and start picking out the things that we want. So, looking at something like this page, where what we've done here is we've filtered it. Now we're looking at the arrivals on green for the North region. So something that we might do in an analysis from this site is start picking out, red dots right here. This might be where we want to focus some effort. We need to see why this dot, especially if it has changed. If this dot did not used to be red, now it is red. That's going to give us an indication of where we need to be focusing our efforts. And that's a big part of what we're doing now is creating these data-driven decisions, right? Where it's the data that is leading us to make the changes in the field. What that means is that by more efficient analysis of the data and quicker intake of the data, that we can start to find problems before they're problems. We can quickly start to see declining performance and adjust it on the fly through the numbers only. We don't have to see it in the field. We don't have to get a report of it in the field. We just start to see a decline in numbers. We see something that's a little bit out of whack, and we make moves on it immediately to kind of proactively manage that area. And again, there's also maintenance components to the SIGOPS metric site. Besides the ATSPM data that we're getting in there, we're also able to see things like detector uptime, pedestrian activations, CCTV uptime. It gives us a good idea of the state of our signals out there. So we talked about data decisions. All right, there's a lot of sources that we talked about in our SIGOPS systems. So we're just going to kind of quickly run through kind of how those come in. We've got the MaxView server. This is kind of the first point of contact for a lot of us. What we do get out of there is real-time emails. Not only we can monitor the system in there, but that thing will spit out emails. We do a lot of things with those emails that we get from MaxView. We get emails for communications alarms, for signals in flash, for detector outages. We're able to take those emails and kind of repackage them and analyze them kind of before and after as well throughout some of the systems that we built ourselves. We've also got ATSPM, which we just talked about, right? And SIGOPS metrics. And again, ATSPM kind of feeds into SIGOPS metrics. It's a lot of the same data, just a little bit different. So we're starting to fill up our data bucket down here, right? Then we've got RIDIS. SIGOPS metrics also ingest some of the RIDIS data, and then spits it back out to us here. We also ingest it independently. So now we've got some things coming in from two different sources. Then we've got other alerts, real-time emails from the 511 system, from RAVE, from actual operators sitting at the TMC that are getting phone calls and reports from the districts themselves asking for specific needs on any given basis. Someone like me who's just driving around and calling somebody and saying, hey man, there's something going on out here, let's fix that. So all of these fill up this data bucket. And what we've tried to do is to efficiently take this data bucket and spit it out into this data analysis wedge so that we can quickly analyze all this data as it comes in. Again, in near real time, this is happening all the time and nearly daily or hourly to daily, to create recommendations from that data and then turn those recommendations into actions in the field. This is continually happening every day, all the time, based on these different data sources that we have. Earlier this year, we actually spun up a dedicated team for data analysis, that their job is to bring in the data sources, efficiently analyze them, and provide a weekly report to the engineers to, again, have these kind of data-driven directives on where to work. I like this chart a lot because what this represents is the dangers of using data if you're not doing it right. This is from a website that it's called like spurious correlations. But in this case, depending on the data that you look at, right, you could potentially say that because we're consuming more mozzarella cheese, we're getting more doctorates in civil engineering, right? So these are things that we need to look out for when we're moving to this data-driven platform, right? We constantly have to look and validate our data to make sure that we're comparing it to the right thing. Here's another one, right? The consumption of high fructose corn syrup is directly correlated with pedestrians killed in car accidents, right? Right. So that one might be true. I don't know. You know, we might have a problem with corn syrup and pedestrian accidents, because that looks really good to me. You know, that's a good correlation. The lesson here, though, is to be careful with how we look at this data, and to really get a good understanding of the data before we make those recommendations and before we take action on the data, is to be sure that we know what we're talking about with our data analysis. Preventative maintenance. We're going to move into this kind of next zone here. Is a huge part, again, of what we do. This one we'll just fly through really quick. Let me go back to that one. All right. So the biggest aspect of preventive maintenance, and I think this is the most important one, is to reduce the calls from the public, because of the ability to find and repair the defects before they become a problem. Again, it's an annual process. We do it once a year at every single signal that we work on that is GDOT maintained. We do not do the preventive maintenance stuff for the local maintainers. All right, I'm going to blow through this one really quick too. But this is kind of an example of our typical break fix maintenance workflows. We're going to start here. The problem is reported, and then we'll create a problem ticket for it. All right, so what's going to happen here is it's going to come in, someone's going to have to verify this issue. And then if they report a no, as we go through this slide, everybody keep an eye on this section, because this is the most important section right here, is this, what I call the no loop right here. And this is what we want to eliminate in what we do, is to eliminate this no loop right here. Because I truly believe that if somebody is reporting a problem, there's really a problem there. And if somebody comes back right here and says, no, there's not a problem, then why did it get called in the first place? Right? There's got to be something that we can do. There's some sort of response that can be enacted in any situation. And that goes all the way back to what we're talking about is do we need to optimize this signal just a little bit more than it already is? What kind of tricks can we pull out of the bag to really make this thing work like we want it to? Right. So we're going to verify the issue. And hopefully we're going to find one. We're going to do a time check. Okay. Hopefully we're going to find one. We're going to find out if we can fix it remotely. And if we can fix it, that's awesome. We're going to fix it, document it, close the ticket, done. If we can't, we're going to see what else we can do, right? All right, so if we can't fix it remotely, what can we do remotely? Right? Can we remotely do some timing changes? Can we monitor this thing? If the detector is out, what needs to happen there to keep traffic moving efficiently while this detector is out? because it's going to get passed up to the technicians now. Okay, now this is going to take some time. All right, we've got to get somebody out to the field if they're not already there. In our regions, if you remember what that map looked like, getting from one side of District 6 to the other side of District 6 takes about 2 to 2.5 hours, depending on how traffic is and depending on which way you got to go. It's not very efficient to have to scramble technicians all the time. You know, we do have fairly good coverage between us and the GDOT technicians, but it's still a lot of windshield time getting from place to place up there. All right, so again, if we find something and we can't fix it, say again, a detection outage, let's do some timing on it. Let's fix some stuff and get going there. Send some technicians out there. Right now, say a technician gets out there and to see if it's an equipment issue, and they come back to no. Now we're back in this no loop, and to us, that's a failure. Right, our entire project is focused on the maintenance side of getting rid of this whole area. Right, we don't want this part at all, and we've done a pretty good job over the past 5 years of getting to that point where we've trained our people, we've built our people up and created our procedures and systems in order to eliminate this no loop right here. Right, the final piece of any break fix maintenance for us, again, if we can't fix it ourselves, is we'll send it out to that OCR project. All right. I think for the interest of time, I'm just going to kind of blow over a couple of slides here. Another tool that we use is Microsoft Teams. We use this a lot for internal communications. But what you can see here too is that we automatically bring in automatically generated notifications through Power Automate programming directly into our Teams feeds, so that everybody can see it all at once. That not everybody has to monitor their email inboxes all the time. But then we can also track an event as it happens between our responses and the automated alerts that come in for that event. This was a incident. We had a bridge get struck on 75, where they actually had to close down 2 of the 3 southbound lanes on 75. So just kind of as an example of what our incident management stuff could look like. So I'll go back up. These are volumes on a normal day during the diversions for the bridge strike. And these volumes were taken from this section right here. During the bridge strike incident, we were pushing twice as much traffic down this route right here as normal. And so that, of course, happened on a Thursday, which meant, of course, they were shutting down I-75 on a Friday, Saturday, and Sunday. So we had staff working all that weekend to help that traffic get through. Were we 100% successful? Heck no, man. We were moving twice as many cars on a on a 2-lane road. We're moving an interstate, down in Arterial. But we did a pretty good job of it. If you look at here, these are some of the speed profiles during the time. The orange line is normal. This is what it looked like on that Saturday. That was our full day of impact. It got pretty nasty out there. But the big takeaway for us was the impact that we had being able to monitor it and remotely work on it was huge. To watch those cars in real time move down these corridors and prepare stuff ahead of them. The big slowdowns you see happen once that corridor became saturated, but they still had a lot of route to go. We kind of estimated at the time about a 20% improvement versus what would have been there and what we were able to run by monitoring. Like, this could have been a lot worse than it was. And this is just a quick kind of plug for our project. We had mentioned in the beginning of the a SharePoint site that we created for this project that is now in use statewide. These are some screenshots for it. What the SharePoint site is for task management. It allows us to kind of like pull everything in together and then dashboard them. GDOT does have another task management platform that this actually ties into. We sync between the two platforms, and that works out very well. Again, I'm just going to kind of go through these just as so you can see them. Finally is the OCRs that we talked about. This is just a kind of quick glimpse of our OCR activity in SIGOPS North. Over the course of the project, which is now at, I think we are in our 5th OCR year. You can see how much money we've spent for GDOT on maintenance work. We get about $1.7 million per year per district for this OCR funding to use. Again, kind of breaking down this way, so you can see also kind of the way that the districts distribute this funding is quite different between the two districts that we work with. So it's a very good program. It's allowed us to have a lot of flexibility and really keep these signals running top notch. One final point on our OCR program is the first year that we did OCRs in District 6 alone. We spent about $950,000 on detection repair, only detection repair. That number in 2021 was $500,000, and we did less actual detection repair because the prices had gone up, and we've kind of held steady at about that point since then. So really quickly out of the gate, it allowed us to fix a lot of things to get things normalized now to a point where we're just kind of going along with it and keeping up with things as they come along. And that is all I had. I don't know if we're doing questions. I don't know if we have time for questions now. I know we started late, so you want to do a few? Yeah.
Mine, on that last flow chart of OCR part, the summary, those color codes are those different types of projects underneath the OCR category. They come off of this pie chart over here.
This one? These are actually the different OCRs themselves.
Okay.
So we'll typically do about 30 different OCRs per year per district.
And what's the flow chart on the top of the color code?
Yeah, these are the types of basically the categorization of those OCRs. So on this one, the purple band here is FYA conversions. This blue color here is detection. So you can again kind of see the distribution between the districts on detection funding. Yeah, no problem. Anybody else? All right. Well, thank you, everybody.
I think we'll get back on schedule a little bit, but I did want to give everybody just kind of a 5-minute break for a few minutes while we get set up for the next speaker. So let's start back, I guess. Maybe 11:15. That's a little more than 5.
It's no way over here now.
All right, we should be good to go.
Got a nice shirt.
Oh, yeah. You like mine?
We're basically
I don't know that he works in here in this building, but I think he is a part of it. Yeah. Yeah, he kind of pointed to the sign when he introduced himself. Do that. So. You think we can get rid of that thing? I want to ask you. Hey, Tyler. I looked at it the whole time. Was it in the- Is there any way to move that or get rid of it? Because it is up there like a.
I think we do it.
Yeah, perfect. Thank you.
Yeah. Thanks for noticing that.
Yeah, it's gonna be just basically,
Well, there was also a right.
well, I just thought we just a little. Okay. They cut through. But still. There's a little bit longer than I expected.
I'm not gonna ever bet you. Okay.
Now that don't wait. Should we just?
I didn't want to just jump in policy. We do. Yeah, we were, Chuck. Yeah. Okay. Yeah, we do, and like we love working with your guys on there, which is really neat because I know Chuck's built a really good system down there, working with pretty much everybody. He's got statewide technicians out there, and he's doing a really good job. Yeah. Yeah. That's awesome, man. Yeah, it's great to meet you.
Hate to break up your conversations, but we're gonna go ahead and get started back. If everyone wants to, we're gonna get started. Let me give you a couple of housekeeping things. If you've come in and not signed in, we would really appreciate just a record of you being here. And if you do need to still pay, TSITE, come see me. Georgia, go see Tyler. And we would really appreciate that. Also, I want to take just a minute. Austin's going to speak for us, but we're going to have lunch right after this. And we want to really give a big shout out to Temple for sponsoring our lunch today. We really appreciate that. It really kept our costs down, and this is a great way to get PDHs for those of you that need them. And we really do appreciate you doing that. With that, I'm going to introduce Austin Harris. He's with the test bed manager, or he is the test bed manager at the UTC's Center for Urban Informatics and Progress, CUIP. You've probably seen the signs around here. He is responsible for infrastructure design, development, and implementation of CUIP and number 39's test bed. In his work at CUIP, Austin helped to develop an open smart city platform to promote research and development in the topics of health, energy, mobility, and transportation. With the initial investment from UTC, operational support from CDOT, communications infrastructure from EPB, and design and architecture support from the Enterprise Center, the Smart City Corridor was launched with a wide array of sensors, computer resources, and experimental wireless networks, which have allowed cutting-edge research across the smart city ecosystem. Processing data, which have allowed processing data from a variety of sensors, including cameras, LiDAR, radar, and audio. The test bed serves to help us better understand how pedestrians, bicyclists, and vehicles interact with the city's transportation network. This information helps prioritize future deployments, realize further research opportunities, and provides a platform that will support testing and validation of emerging technologies while continuing to address the city's goal for safe and efficient mobility for all citizens. So please welcome Austin Harris.
Good morning, everyone. I'm going to be sharing a bit more about our smart city connected vehicle testbed, the MLK Smart Corridor. Before I do that, I've got to figure out how to change slides first. There we go. Before I do that, I want to quickly introduce the Center for Urban Informatics and Progress, where I am the testbed manager. The center is a multidisciplinary research center at UTC here locally. This is our space that we're in today, if you can't tell by all the banners around. And our backgrounds are in data science. We take a data-driven approach to look at the areas you can see across the bottom of the slide here: mobility, health, energy, social science, public safety, as well as water, to better the lives of the citizens here in Chattanooga, Tennessee. Back in 2017, we had a very common problem, which was data scarcity, as we were developing some of our applications and conducting our research. So we took a couple of access points and a couple of cameras, and we installed them ourselves on one of the roads right within the University of Tennessee at Chattanooga's campus. It was very small. I think we had 2 cameras and 2 access points, and we were developing an application which we called see-through, which allowed onboard cameras, onboard vehicles to basically gather context awareness through sharing data between vehicles. And that was our first, what I'll call a test bed. It was quite small, and it was there for a limited time. And that's what led into the deployment of the MLK Smart Corridor, which was deployed in 2019. The MLK Smart Corridor, which is fully deployed, is located where you see these green markers here. These are all signalized intersections. Matter of fact, we are located right here. So 2 blocks over on MLK is kind of the closest point to the test bed. So this was established, it's been deployed, been collecting data, and been supporting research for a couple of years now. Back in October of 2021, we received funding to expand the testbed onto Highway 27. That way we could look at different use cases, as well as have through a new environment and collect different types of data based on the highway. So that is in the progress right now. As well as earlier this year in 2022, an additional 27 signalized intersections were funded. These run parallel. These are the red locations here. These run parallel to MLK, as well as pick up where the original test bed left off. So at each of these locations, we have a wide variety of technologies. We have multiple cameras at each of those signalized intersections. We have audio sensors, so microphones, air quality sensors, 2 LiDAR. From the sensing perspective, we have, from the communications perspective, we have software-defined radios, so you can configure your own network. We have standard access points. We have dedicated short-range radio roadside units. Those were deployed in 2019, and we are in the progress of updating those to dual mode DSRC cellular roadside units at the moment, as well as we have what's called LoRaWAN, which is for IoT devices. Additionally, we have a wide array of edge computers, some general purpose computers, some more focused toward machine learning and AI, so that some of these applications can be processed there at the edge. We designed this in a way that it's scalable, it's modular, so we can extend, add new sensors, as well as applications. You can see on the right side that some of these are actual pictures from Martin Luther King Boulevard and Georgia Avenue, showing these devices as well as the cabinet there. So when we deployed this to test bed, we wanted to develop a infrastructure to support the data ingestion. We wanted to support real-time applications. We wanted, as well as to be able to collect, a wide range of data. At the time, we didn't necessarily foresee all the different data types. We wanted to make sure it was flexible in that sense, as well as replicable. It could be picked up and placed elsewhere if needed, and scale as the test bed continued to grow. So here you can see on the left-hand side, you can see some of these sensors as well as data that we ingest. On the next layer, some of the communications. All these intersections are backhauled by fiber, as well as that data is passed in at the edge and into our data infrastructure. We store the historical data, which we utilize for modeling, machine learning, as well as we utilize the real-time streams for application development. So the different types of data that we collect include the SPAT data at 10 hertz that comes in from the traffic controllers. We collect road user movement and counts from the video analytics that we run on our cameras, as well. Very similar data comes from the LiDAR and the perception that we run on top of the LiDAR of air quality sensors. The city has grid smart detection devices out there, so we stream in their data, as well as collect the reports at the end of the day, as well as communications from connected vehicles. So we have a connected vehicle that we utilize to collect data on the test bed, and that data gets just pushed directly from the roadside units as it comes in into our infrastructure. Currently, we ingest just over 2 billion data points a day through our infrastructure, and that's with the 11 signalized intersections. So it will scale up pretty significantly as we continue to expand. We have a dashboard where we monitor all the infrastructure as well as the data that comes through. We can explore the data and pick up on patterns that we have developed. So one of the goals that we have for the test bed on its own, not regarding the projects that it supports, but the test bed itself, is to develop this as what we call a test bed as a service. And it's really developing out and streamlining the use cases and making it the data accessible as possible. We're currently working, this will be done through a web-based portal where users can log in and access the real-time data, access historical data, as well as provision applications out to the edge, reserve resources, as well as configure networks. So this is currently in the process. I mentioned earlier we have a connected vehicle that can also be utilized by users of the test bed. And additionally, we have another vehicle that's funded. It hasn't been completed yet, but is a autonomous vehicle research platform that will accommodate the connected vehicle as well. So getting into how some of the applications that we developed that were on top of the test bed. One, of course, is video analytics. We developed video analytics that we run there at the edge 24/7 that provides us the pedestrian as well as vehicle, bicyclist movement at each of these locations. We track the objects as well. So instead of so we can derive turning movements from this data. You can see on the left-hand side, the sensors again, where those videos are streamed in, and we process that in real time. And the output that we get, I'll show a video in a minute, but basically we can see along at each timestamp or any given time, where an object was, so we can closely track it in comparison with other objects. Additionally, we also use our video analytics for speed estimation. That way we can, and also later on the presentation, I'll talk about how we're using that in some of our other applications. I've got a short video I can play here. The speed is used, I believe it's in the next slide, for our near miss algorithms that we've developed that run 24/7 as well. These provide near miss events, basically when action must be taken to avoid any accidents that occur. Move on to that one. There we go. So here you can see this is MLK in Georgia as well. This is one of the events, one of the near miss events that we had recorded, and a pedestrian. Let me rewind it quickly. You can see this pedestrian crossing on a don't walk signal here with the person, the vehicle turning behind it. Let me replay that. So basically we look at speed, trajectory, we predict the trajectory of the vehicle, and we calculate what's called a time till collision. As far as the type of data that we collect, you can kind of see the historical markers of a vehicle or a pedestrian as it moves along. All that data is ingested into the infrastructure. And I should also mention, when the testbed was deployed, we had a community engagement where we invited all the community members to come out so we could discuss what the plans were for the testbed. And one of the things we want to make very clear is collecting personally identifiable data is not within the scope. So we don't, as I mentioned, we collect the video process the video in real time, but we do not store any of that video. Sometimes we have an agreement, we can store small snippets in order to validate our computer vision, but we do not store the data. I've had calls, as you would imagine, from CPD and others looking for video data from different incidents that we weren't able to provide, of course. So the city tasked us with the near miss project I was just discussing, and we developed our near miss algorithm using the video analytics. However, as you would imagine, with video analytics, you only kind of have a two-dimensional frame. It's hard to understand that depth component. So we actually decided to deploy LiDARs out on the test bed. This would have been about 2 years ago. To see compare the performance between the video analytics and our perception, the LiDAR perception, 3D perception. So after that project was finished, one of the things that we've been looking at is fusing these two data streams. So fusing LiDAR as well as video together, because sometimes video picks up things that LiDAR don't pick up, sometimes vice versa. As well as obstructions play a large role in the video analytics, where with LiDAR, they are fused into a single environment. So we can see, behind a vehicle, for example, if an 18-wheeler pulls up to the stop bar, we can see what's on the other side. Here I have a near miss. It's the same recording from video analytics as well as LiDAR. I'm going to play quickly. Try to play them at the same time if it'll let me. So you can see on the video frame, the silver car pulled in between the pedestrians walking across the crosswalk, and on the left-hand side, you can see our LiDAR perspective that we get. time's sake, I'm gonna skip this slide. It's very similar, looking at accessibility and how we can utilize this real-time data to, from an accessibility standpoint, you know, like whether it be extending the phase in order to give someone more time to cross the crosswalk. So the last project I want to discuss is one of our pedestrian safety through cooperative perception. So I've mentioned how we collect the data around pedestrian movement, as well as I've mentioned the communications that we have out there. So one of the things that we are looking at is using infrastructure-based sensing to deliver safety messages to road users. And by using infrastructure-based sensing, we can represent, you know, non-connected users in that space as well. By using whether it be LiDAR or cameras, radar, whatever the sensor may be, you know, identifying safety scenarios and providing that feedback back through whether it be a mobile app or a dynamic message sign there at the intersection, or providing it to connected road users via the roadside units there at the intersection. This is a project that's really just begun, but I wanted to include it as it utilizes the infrastructure, the existing infrastructure on the test bed. And the last one I'll go over is our digital twins with the simulation environment that we've developed, that we can replay scenarios with the data collected along the test bed. So using all the data that I've discussed from the traffic controllers, the LiDAR, the video analytics, we can actually use this environment for testing, whether it be traffic control algorithms, you know, whatever the use case may be, we can actually replay those scenarios in the simulation environment or digital twin. And here I've got a quick video. The lines that you see there, those are the status of the signal. So this is an environment, this is the simulation environment that you can see here. These vehicles represent vehicles that were detected, as well as the signal and signal phasing and timing for that specific intersection at this point in time. In the last slide, I'll quickly mention, you can see the current phases of deployment that I mentioned earlier in the presentation. More recently this year, a project was funded that will deploy these technologies to the entirety of downtown Chattanooga. It's give or take 100 signalized intersections. So the technology I had mentioned earlier in the presentation, this will be deployed throughout the shaded area here on the map. I believe that's all I've got for today. Thank you, everyone. Do we want to do any questions, Karen? I know we were running tight. Okay.
Okay, so you don't keep anything recorded at all, so lawyers aren't calling you?
Exactly. We don't record, I should say, so LiDAR data we can record because there's no way to identify anyone in it. And we store all of the data, but none of the raw video is the main one at the moment. We don't store any raw video where you can visually identify someone or, you know, pick out a license plate. That's the main one. So we process that data as those videos, as you saw in some of these videos. You know, the data that we get out basically tells us exactly what's happening, but with no identifiable data.
Are there any plans to collect controller data?
So we automate we have Siemens M60s on the current test bed. We download the SPM files, which aren't necessarily real time because they're aggregated on board the controllers, but we do get the 10 Hertz SPAT data that comes in, that gets streamed in real time. Can show, tell her, could I show something on Google Chrome real quick? Is that okay? I can share just briefly. But so that the signal phasing and timing data comes in for each of those intersections. So it happens quite quickly. I know this isn't a great visualization, but it's coming in quite, so as soon as this page loads, so this is from the detector system here. Let me open it up, maybe you can see it a bit better. It's not a great visualization, but so these are some of our intersections here. Each one of these records, GridSmart generates data, with the volumes for each zone or each approach once a minute, and then they push those out. So those are coming in here. So if we sit here for another minute, we'll see those stream in. And then below this, if I can scroll, you can see how fast the SPAT data is coming in here.
Can you pull in the GridSmart images?
Yes, we can. And yeah. Any other?
On your test corridor, do you have any applications that are available to anyone who has an onboard unit, if they so choose? All the ability for autonomous test bed.
So in a sense, if they're driving through, they can take advantage of. Sure. So we all of the intersections are set up for the standard SPAT map messages at the moment. And of course, they can intake BSM messages that we ingest into our system, as I mentioned. But beyond that, not at the moment. Any other questions? All right. Thanks, everyone.
Okay, I think now it's time for lunch. So let's see where we're at with our schedule. Somehow we made it back to our schedule. So the way we've got it set up in here, there's box lunches. So in front of each lunch, you'll see a description of what's in the box. So feel free to it's kind of first come, first serve. And then come back in here and enjoy it. But we do have a little short presentation from Temple during lunch. So we'll get that set up and there's drinks and everything. If you need anything, just let me know. We will meet back, I guess, at 12:20 will be our time back.
Need to hit me with that QR code.
Oh, yeah, it didn't work, did it?
There's my side.
Okay. Unmute.
Then how do I advance? Do I
Just do the
Yeah,
right button.
Okay, yeah.
Yeah.
So you're getting blinded.
I'm great.
Are you with the
Yes.
Tennessee side?
I am. You're with Georgia and you're with. Yeah, I'm with you.
What part to that?
Traffic.
Okay.
Yeah.
One of the reasons I'm here is meeting you, talking to you guys more.
Yeah.
Like everybody here, we're growing in Tennessee, trying to make more those.
Yeah, actually, I told it myself for 19 years. Whenever you see that.
Now you're back around.
You know, it's just a different side.
All in Tennessee.
Yeah. Yeah, I was with our students last year, and then over, coming out of college. So, now it's.
Maybe it's Nashville.
I'm actually here in Chattanooga. Yeah. Thank you for coming today.
Oh, yeah.
Yeah, I did. Nice to meet you. I'm not, I'm doing more. Well, I had non-farm.
Tim, when are you getting all set?
Yeah. What you gonna do about it? But yes.
Now we all have to buy it controlled really.
Yeah, right, I did it now.
Whatever. Mike Baker.
Okay.
So. And used to. Talking dinner. So I hear it's for that this weekend.
Yeah, I come around May.
Okay. Did you get sick? You got hit?
Okay.
I came back.
Really? Yeah. But I just got.
Okay. I had my flu shot 3 weeks ago.
Really?
And then I spent Thursday and Saturday just lying in bed.
I'm talking. I don't know, I've heard.
It's sometimes it's, but you know, it's always, it's like, you get it, it's gonna be less. Probably in the roofs, yeah, it's never going down.
So, you know, but I've got a car, he does, so he's gonna be on his speed.
Yeah.
So we thought.
My interaction with the wall has, we don't do a lot of single planning, so you get ops kind of things up, so it's more when I have a planning with question.
Yeah.
They're asking me this question, I don't know anything, tell me that.
I mean, I've been fishing down. Yeah. Not very. Fishing with things.
Okay. Good luck. We want more food. Maybe. Just the cookies.
Good to see you. You get it. You get it.
Here. Joe, what's going on?
Oh,
We're kind of wrapping up our first River Valley, when the second one. They start January. Where it was Thea.
Talking about the Thea project.
Yeah. We're southern door, it's not. It's done. It started a lot later with.
You got Carl, you're not here. Carl, this is Carl. John and I work together on various projects. I'm just wondering elsewhere.
Have you seen Ray Kane? Not yet. After. He's not thinking for one good thing. Yeah. The still if I need it. The still if I need it.
Okay.
I mean, it's still,
It's got time.
you know, hour and a half.
We're gonna take you up there.
Not really, I mean, I'm aware of this delivery, yeah, I know that. Well, it doesn't make sense, I'm starting in 23. They'll be out there.
So far, so good. It's part of the. You know, yeah.
Yeah, we're gonna have a couple of batches. For
What's the on?
I know for sure, it's probably gonna be like a streetscape, and there might be some other stuff. But
It'll be.
ones that maybe not be a perfect fit, or like an individual contract. Kind of a discretion, I guess.
Subdivision.
Where you're saying this, right? Some of the stuff I'm going on, we're shutting the book because we can't see.
One over at Mount Johnson there, yeah.
Yeah, this is Roswell Road, CDBG sidewalk.
Oh, no.
Almost. Just can't get it because soon. And I've had two more PMs. This one grenade is. She's brand new. So it's me. Oh.
Is that the one that? Marta. That's something different.
Here in March, we're gonna let our sponsor give a little short presentation, then we'll have more time to kind of talk to each other, but I wanted to give him an opportunity since he was so generous to help us out here, so.
Thank you, Karen. Yeah, sponsored it. So, yeah, I'm Tim Britt with Temple. Karen gave me an hour to talk, so I need to get on this to keep us on schedule right now. So, I don't know how many of y'all are familiar with Temple or not. We've been around almost going on 70 years now, based out of Decatur, Alabama. I've been with them. It'll be 12 years this December. So, so yeah, just kind of wanted to give you a brief overview of what we do, some of the folks we represent through our 9-state territory in the Southeast. Like I said, we've been around getting close to 70 years. We're founded in 1954, based out of Decatur, which is about 2 hours from here. Chattanooga has been a great partner of ours. They've got our central management software installed here and just been a great customer of ours for many years. And we're thankful for them. Like I said, we're a family-owned business. We're now in our 4th generation, which the family's very proud of that, to see the company see that many generations. Something that we're also proud of is everything that we sell, we support. So we have, technical support, field service support that can come out and help you get something set up, train you on maybe a new device that we've installed for you, troubleshoot. It's like I tell everybody, I said, if somebody says you're never going to have an issue out of a software or device out in the field, they're lying to you. Unfortunately, we all have issues, but how are you going to support that issue? And that's something that Temple, we pride ourselves on, is that we support our products out there in the field. This is just a map of our 9-state territory. The big star there in Alabama, that's our main office. I live in Decatur, and that's kind of a good central point for my territory. I cover everywhere in Tennessee, but like the Jackson, Memphis area, we have another rep that covers there. And then I cover Alabama as well everywhere, but like the Mobile, Baldwin County, that small star there in South Mississippi, Jeff Smith, he comes over. It's just more logistical, makes sense for him to cover that area. And so out of our head office, like I said, so we are the traffic signal shop for the city of Decatur. So, as we go around and see these municipalities and contractors and, whoever it is, we have folks that experience things in the field just like they do, whether they're seeing signals going to flash or again, issues with, a product out in the field. So if a signal goes in flash in Decatur, they're calling us, we go out, rectify the issue. Over in Georgia, we have 2 sales reps for you Georgia folks. I got their contact information at the end, or you can reach out to me if you got any questions. Colton Hill, he does Metro Atlanta area, and then Adrian Baker kind of does the rest of the state for Georgia. And we also have, again, a technical group over there that does field service work for us that cover Georgia and the Carolinas for us. We've got 2 sales reps down in Florida and a technician down there as well. We got a sales rep that covers North and South Carolina for us as well. So that's our 9-state territory in the Southeast. These are products that, vendor partners that we represent in that 9-state territory. The only one that we do go outside of that territory is you see the Temple edge lip there at the top between Polaire and Clary. That's illuminated street name signs. So like Franklin, Tennessee, if you go over there, they're a big user of those street name signs. If you go down in Alabama, you go to Auburn or Tuscaloosa, they all use those illuminated street name signs. We got scattered everywhere else, but so we have partners like us in the rest of the country that represent that product line for us, and we build those right there in the city of Decatur. So those are coming right out of there. We can put, like University of Alabama, they do that script A on the sign. We can do city logos. Auburn has their Auburn on the bottom, their Auburn blue, and stuff like that. So we got, I think, one in Iowa, and it's got the Iowa Hawkeye on the side of it close to campus. So, different things like that. But yeah, we're fortunate to have a lot of great partners. Clyde Information there at the top left. They do a lot in the connected vehicle world, but also, cabinet monitoring, things like that. We heard earlier talking about cell modems and stuff like that, getting that comm back. But, they do so much more than just a cell modem, where it provides you with connected vehicle. It provides you with door alarms, signal goes in flash, you lose AC power, just all different kind of aspects of that. Polaire there as well at the top, they do, again, pedestrian push buttons. So, now audible push buttons are becoming very popular. They're the leader. I can say with great confidence, they're the leader in the industry when it comes to audible push buttons. They've got great reliability. They're the only ones that have they actually are on the ADA access board. So they, know what the visually impaired is looking for to be able to navigate intersections and things like that. Luff, their weather, we do weather equipment. Unix, which was formerly Siemens, that's a traffic signal controller. And, now they do all the high density data and signal performance measures and all that stuff that everybody's looking for in that regard. Iteris, they're a great detection company that we represent. They also have a signal performance software to make it easy. A lot of people say, hey, we want that signal performance measures, but then when that local agency says, hey, all right, we give you that signal performance measures, then they see all that data and they're like, I don't have time to break all this down. What do I do with it? They have a software that makes it very easily, puts it in charts and graphs and things like that. Curix Vision on the left there, that's one of our newest partners, and they, as we get into AI, visual learning, all that, they're big into that. I think they got some over in Georgia. I know where at out on the interstate, and we're deploying some in Alabama. We do a lot with universities. We're working with Austin, his Smart Corridor, University of Alabama. They've been a big partner of ours over the last several years as well. So all different kind of folks that we represent. So if, you know, something there strikes your interest, let me know. I'd love to set up a meeting, whether I love in-person meetings, but if we need to do something virtual, we can do it that way. And then for you Georgia folks, that's Colton and is in the metro Atlanta area, and Adrian is the rest of the state. So talking about like applied information over in Georgia, I don't know if you Georgia folks know, they do a school zone system as well, where you can communicate remotely to your school zones. And so Georgia, the DOT, they did it statewide. So you pull this map up, and they got these icons, and it's basically covered up with 900 something school zone beacons, and it's in the shape of the state of Georgia. It actually looks pretty cool. But so yeah, any questions for me?
I'll mention, I worked off and on with Temple for 40 years. And they've always been able to supply either information or equipment or support on the projects I've worked on. So, you know, can't go wrong. And I'll talk to you about.
Thank you, Steve. Well, I just gave you lunch, right?
But I really enjoyed working.
No, appreciate that. Yeah, we're fortunate to have people, you know, I'm just a dumb salesman. I mean, I've been there, like I said, going on 12 years, but you know, you've heard the name Dave Griffin, I'm sure, if you've done anything in the traffic industry. And we've got all kind of folks that have been there 20, 25, 30, 40 years. And we have been fortunate with that. So thanks, Steve. So yeah, no, appreciate y'all letting us support it and get y'all lunch. And thanks for the opportunity. Thank you.
Enjoy your lunch. Yeah, we'll start back about.
Okay. Yeah. Okay, you. I'll delete it off of here. It don't matter. You keep it.
Was that confidential information?
Help you go to bed at night. There's a bunch of other slides. You can look at.